Okay, so now let's look at the example 1. Okay, find the absolute extremum of fxy equal to x squared minus y squared. Okay, on the region R, which is R is minus 1 to 1 and y is minus 1 to 1. Okay, so we know that this is closed and bounded case. Okay, because we have the region from minus 1 to 1. Okay, alright, so now we want to use the previous theorem to solve this. Okay, so our first step is to find the fx and fy. Okay, so we know that we have the fxy is equal to x squared minus y squared. Therefore, our fx is equal to 2x and our fy is minus 2y. Okay, alright, so for the second step is we need to equate the fx is equal to 0 and fy equal to 0 in order to find the critical point. Okay, alright, so now fx is equal to 2x, which is equal to 0, therefore x equal to 0, and the fy is equal to minus 2y, which is equal to 0, therefore y equal to 0 as well. Therefore, we will have our critical point, which is 0, 0. Okay, so now we want to test. Okay, we want to find the value of f, okay, on the critical points and also the values on the boundaries. Okay, alright, and then we can compare. Alright, therefore what we need to have is the point that we're going to look at is critical point, and then boundary point. Okay, so for the boundary points we have x is minus 1 to 1 and y is minus 1 to 1, so we need to consider all possibilities. Okay, like, okay, from minus 1, for example, x is minus 1, y can be minus 1. Okay, and also from minus 1 the y can be 1. Okay, alright, so if x is 1, so y can be negative 1, and for x is 1, y can be 1. Okay, alright, how about the critical points and the boundary points and the boundary? Okay, alright, it can be for critical point x 0, the boundary can be from negative. Okay, and also if the critical point 0, the boundary also y is negative 1 and 1, right? Okay, alright, so how about if y this time is 0? Okay, so the boundary for x is minus 1 and 1. Okay, so now we need to consider fxy, okay, for all the points here. So we need to have fxy equal to x squared minus y squared. So we need to consider for f00 first. Okay, for this one here, f00. Okay, so it will be 0 minus 0 is 0. Okay, and then we need to consider the next one here, f minus 1 minus 1. Okay, so it will be 1 minus 1 is 0. And then we need to consider the next one, which is f minus 1 1. Okay, so it will be 0 as well. Okay, next is 1 minus 1 minus 1. Okay, so it's still 0. Okay, and then for the boundary point, the last boundary point here is f11. Okay, so f11 also 0. Okay, so now we move to the critical point and the boundary point, which is 0 minus 1 for this one here. Okay, so we'll obtain 0 minus 1, so minus 1. Okay, and then f01. So for f01 here, okay, so it will be 0 minus 1. Okay, so it's still minus 1. Okay, so for f minus 1, 0, so it will be for this one here, minus 1, 1 minus 0, so 1. Okay, and last one f1, 0, which is 1 minus 0 is 1. Okay, that one is step 3. Okay, so step 4, the final step is we need to compare. Alright, we need to compare the highest value and the lowest value. So from here, if we can see, the highest value is 1. Okay, and the lowest value is minus 1. Okay, so we can write it here. The highest value is 1 and the lowest value is minus 1. Therefore, what we can say here is absolute maximum is 1. Okay, so this is the absolute maximum. Absolute maximum is 1 and the absolute minimum, okay, is minus